All right, so if we look at this first question, what a lot of you did was you just stacked them all and added them traditionally, which is totally fine, but I'm just going to share another strategy with you just to see another way that you could have approached it. So what you're going to notice with each of these numbers is there, so for example, in this digit, there's an 8, an 8, an 8, and a 3. In the next place, there's an 8, an 8, a 3, and an 8. This pattern continues. So I'm just going to erase that so you can see it. So in each of the ones place, tens place, hundreds place, and thousands place, there is 3 8s and 1 3. So a little bit of a faster way would be to think, what's 8 plus 8 plus 8 plus 3? You're going to get 27. And then basically you're going to realize that you're going to have 27 ones, 27 tens, 27 hundreds, and 27 thousands. Whoops, I've messed up where that is, but 27, let's see if I can, I can't move it, 27,000. And then you can just add those up. It's a little bit of a faster way, just another strategy to share with you if you're interested. This one would be a lot faster to do sort of mental math. So let's look at another problem here. So this one, I think a lot of you just didn't read it carefully. So what you're going to see here is that it said that 2 students were 3 away from the actual number. So you're looking for 2 answers then that are 6 apart. Because if this is the actual, if you've got the actual number, and this person's 3 away, and this person's 3 away, then between those 2 people, there must be 6. So when we look at these 5 numbers, what 2 numbers in these 5 numbers are 6 away? So for example, 98 and 105 are 7 apart. 105 and 109 are 4 apart. 109 and 113 are 4 apart. So which 2 numbers would be exactly 6 apart? And you're going to notice that that would be Candace with 109 and Edward with 115. So 109 and 115, those are 6 apart, which means the actual number must be 112. So then where a lot of you went wrong is it says, who won? And here it says the person with the closest guess wins. So Candace and Edward did not win. They were just the 2 that were 3 apart from the actual number. Which of these 5 numbers is the closest one to 112? And what you're going to see is that 113, or Dennis, is the closest one to 112. So Dennis is the one that actually wins the contest. So a lot of you, I think, were close on this. You just didn't quite read what the question was asking. So this next one, one approach to doing it is to realize so that the letter N, for example, needs to be equal to 20, well, 9 plus 9 plus 9 equals 27. So the letter N will be 7, and you know that you had to carry a 2. And so that means that 3 A's plus this 2 that you carried has to be equal to an A plus, and then you realize that you had to obviously carry something else. So you're either going to carry a 1, which means it would be A plus 10, or you might carry a 2, and it might be A plus 20. Thinking about it carefully, you couldn't carry a 3 because you're not going to get something that adds up to 30 something with only 3 single digits. So the highest you could get, if A was a 9, which it actually can't be, but if it were, the highest that you could get would be 27 plus the 2 that you carry, which would be 29. So it has to be one of these 2 options. So I'm just going to show you a little bit of some quick sort of algebra here for people that are interested. If I want to get all of the A's on one side so that I can figure out what A equals, what I have to realize is that this side, 3A just means A plus A plus A plus 2. And that's going to be A plus 10. So right away, I notice that this side has an A, and so does this side. So I can actually cancel them out. So I'm left with A plus 2 equals 10. So the other thing that I can realize is if I get rid of this 2, I can cancel it out. Except in math, I can't just get rid of something. If I do something to one side of an equation, I have to do it on the other side of the equation. So I'm actually going to just erase this right now. And I'm going to end up with 2 a's left on this side will be equal to 8. So a could be 4. Then I'm going to investigate. Remember I said it also could have been 3a plus 2 equals to a plus 20. So I'm going to use the same strategy. If I do the same strategy here, I'm going to cancel an a on both sides and be left with 2a on this side. And if I take that 2 away from both sides, I'm going to be left with 18, which would mean that a will be equal to 9. But right here it says that no letter can be 9. So I know then that a has to be 4. So I can come back to here and I can replace those a's with 4s. And I was carrying the 2, so 4 plus 4 plus 4 is 12, plus 2 is 14. Carry my 1, this will end up being 16, and that is going to be my answer. So this one here, hopefully you notice that there is a pattern. It repeats 3, 8, 4, 6, 1, 5. 3, 8, 4, 6, 1, 5. So as soon as you see something of like, what's the 2019th digit? You have to realize that this is not thinking that you're going to have to write this out 2019 times. What you're going to use is the pattern. So notice that there are 1, 2, 3, 4, 5, 6 numbers before it repeats again. So really all you need to do is figure out what 2019 divided by 6 is. So when you do that, you're going to get 336, and your remainder is going to be 3. So what that tells you is that this will repeat 336 times exactly, and then you're going to have 3 more numbers. So it means it goes through the 3, 8, 4, 1, 6, 5, and then there will be 3 more numbers. So if you just count, there will be a 3, an 8, and then a 4, which means the 2019 digit must be a 4. All right, this final one I think stumped quite a few of you. And I know some of you have been working with divisibility rules. So a couple things to keep in mind. If the number is divisible by 5, that means it has to end in a 0 or it has to end in a 5. So right off the bat, it can't end in a 5 because that isn't one of the digits that you're given. So there are 1, 2, 3, 4, 5 digits, and so we know that it must end in a 0. Now, the other one that's kind of interesting that I don't think we spend a lot of time teaching is the divisibility rule for 11. So when a number is divisible by 11, the alternating sum and difference of the digits from left to right must be divisible by 11. So what I mean by that is if I have the number 9 to 5,381, that means that if I alternated the sum and difference of those numbers, so 9 minus 5 plus 3 minus 8 plus 1, so that becomes 4 plus 3 is 7, minus 1 is negative 1, plus 1 is 0. And in this case, 0 is divisible by 11. So I want to try to make a sum, alternating sum of 0. So if I'm left with the numbers 1, 2, 3, and 4, to alternate them so that I end up with 0 as a sum, my 1 and 4 have to alternate with my 2 and my 3. So for example, I could be 1, 2, 4, 3, 0. I could be 2, 1, 3, 4, 0. Or I could be 3, 1, 2, 4, 0. The other possibility would be 4, 2, 1, 3, 0, but it says that the leftmost digit is not 4. So it can't be that one. So again, just to review that, so if I did 1 minus 2 plus 4 minus 3 plus 0, I would end up with 0 and so on and so forth. So now what I need to do is think about the divisibility rule for 8. So the divisibility rule for 8 says that the last 3 digits must be divisible by 8. So I'm going to look then just at these last 3 digits. And the only one of these that is divisible by 8 is that one right there. And that is going to be my answer for this question. If you have any questions about these problems, please come and talk to me. A lot of you did really well. You gave some really good attempts, and you were really close or on the right track to a lot of these questions.